you ever held a cold water bottle in your hands and wondered why after a while the temperature of your warm hands and the cold water bottle kind of become one? Hi, my name is Adriana Morono, and today I'm going to be explaining to you the concept of thermodynamics. And don't worry, I'm an AP Chem survivor, so I am very qualified to teach you guys. Before we even start talking about thermo, we have to know about energy. Energy is the capacity to do work or to produce heat. And by work, I don't mean stamping in your timesheet, and by heat, I don't just mean getting hot. Heat is the transfer of energy between two objects due to a temperature difference. Now, it's important to note that temperature doesn't simply mean getting hot or cold. Temperature is an index of kinetic energy. And work is the force acting over a distance. Here we have the first law that we need to remember, the law of conservation of energy, which states that energy can be transformed into one form or another, but it can never be created or destroyed. And speaking of energy, we have two main types of energy in thermo. We have potential energy, which pertains to position and composition, and kinetic energy, which talks about motion or mass. Now, let's get to the nitty-gritty of thermo. Basically, thermo discusses the existence of a system and a surrounding. If you think of yourself as a system, your entire body as a system, you can think of the universe or everything around you as the surrounding. The whole concept behind thermo is the flow of energy. So when energy flows out of the system, when heat is escaping the system, it's called an exothermic reaction. And the way that I remember exo, exiting, is like an exit sign, exo, exit. And here we have a formula that demonstrates an exothermic reaction, where methane plus 2O2 creates carbon dioxide and 2 moles of water plus heat. In this reaction, the bonds in the product side are stronger because heat is in the product side. And here we have another example, when energy flows into the system, endothermic. I remember this because humans are endothermic, they can heat themselves. And here's another example where N2 plus O2 plus heat is in the reactant side, equals 2 moles of NO. The most important concept of thermo is that energy gained or lost by the surroundings must be equal to the energy gained or lost by the system. And here we have two very important decrees of thermodynamics. The 0th law states that energy has to flow from high to low temperature, and the first law states that the energy of the universe is constant. Now, while I'd like to keep teaching you about bomb calorimetry, coffee cup calorimetry, or show you one of my favorite equations, this is all that I have time for today. And I hope that if I get this scholarship, I'll be able to teach you all about my favorite parts of calorimetry.